In this section, we're going to talk about DHCP protocol, and let's go ahead with the DHCP version 4 first. DHCP is a client-server protocol that automatically provides IP host with its IP address and other related configuration information such as subnet mask and the default gateway or the DNS or something like that. DHCP uses port number 67, and for example, if you are managing a network with 1000 clients, it is almost impossible to assign IP address configuration manually for each client, so DHCP is almost mandatory for big corporate networks. DHCP process goes through 4 stages while assigning an IP address to the client. These stages are often abbreviated as DORA: discover, offer, request, and acknowledgement. In the discovery stage, the client sends a broadcast message on the network, as you can see in here, and searches for an active DHCP server. When a DHCP server receives the DHCP discover message from a client, which is an IP address list request, the server reserves an IP address for the client and makes a list offer by sending DHCP offer message to clients. In response to the DHCP offer, the client replies with a DHCP request broadcast to the server requesting the offered IP address. When the DHCP server receives the DHCP request message from the client, the configuration process enters the final stage. The acknowledgement stage involves sending a DHCP ACK packet to the client, and this packet includes the list duration and any other configuration information that the client might have requested. Dynamic host configuration DHCP protocol is a server protocol assigning dynamic IP address to the computer. A DHCP server enables computers to request IP addresses and networking parameters automatically, reducing the need for a network administrator or a user configure these settings manually. We can also use our routers as DHCP servers, and here is the configuration. To configure a router as a DHCP server, first we need to define an IP pool by typing IP DHCP pool and the name of pool, which is my pool for this example. Okay, then we are getting into DHCP config mode, as you can see, and we are typing the address range firstly. The thing we are gonna define for this address range, we need to type network command, and we need to type the network ID with a subnet mask, okay, which means our range will be between 1041.10 to 24. Okay, I'm gonna start from 11 to until 204. Okay, then we're defining a default router, which is the default gateway, and default gateway of this network will be this interface of this router, which is 1041.11. okay, then we are defining a DNS server, and our DNS server will be this. Then we are also defining a domain name, which is networkl.com. okay, what I'm doing in here also is, as you can see in the last command, I'm defining something more. IP DHCP excluded address and 112.15, which means I'm excluding this range. Okay, I won't use this range. That means, so the address range for PC1 will be starting from 1 to 6, because 1 is our default gateway and won't be used, and I'm also excluded this range, which includes my default gateway too. Because of this, the address range that PC1 can use will be this range. To verify the DHCP server options of a router, we can use show run section DHCP, show IP DHCP binding, and server statistics commands. If you want to assign a dynamic IP address to a router's interface, you can use IP address and DHCP command under the related interface mode. This is not something that we are usually using, but you may face with these questions in your exam. So in here, we are getting into the interface mode by typing interface gig 00, which is here, and by typing IP address DHCP command, router's gig 00 interface gathers an IP address from the DHCP server dynamically. The most common use of router for DHCP services is the DHCP relay. DHCP relay is the router forwards DHCP broadcast packets to DHCP server, which is also known as the helper. For example, if PC1 makes a DHCP request, router 1 will forward these packets to the valid DHCP server, which is 1041.25 for this example. Let's go ahead, DHCP version 6. IP version 6 prides itself as a protocol that supports many dynamic plug and play functionalities. As a result, there are multiple ways to assign IP addresses in IP version 6. To configure a IP version 6 host global unicast globally, we have two options, and they are Slack and DHCP version 6. In Slack option, router can send IP address, prefix length, and the default gateway information to the clients. In DHCP version 6 option, DHCP server sends IP address, prefix length, default gateway, DNS server, and domain name information to clients similar to IPv4. Let's go ahead with the Slack. In Slack option, a router can offer three types of information to assign dynamic IP address configuration. The first is Slack only. In this option, router offers to use the information that router sends only. In the second option, which is Slack and DHCP version 6, in this option, router offers to use the information that router sends and offers to receive the rest of the options from the DHCP version 6 server, for example, DNS or something like that. In the third option, router offers to use just DHCP version 6 server. Okay, this is how Slack works actually. The host makes a request first, which is a router solicitation message, and saying that, hey router, I need IP version 6 options. Okay, our IP version 6 router gets this request and can reply in three ways. The first reply is Slack only, which includes, here is your IP prefix length and the gateway, replying to the host. The second option is Slack and DHCP version 6, which includes, here is your IP prefix length, but ask the DHCP version 6 server for DNS and the domain name. In here we are defining something we are providing some of the information from router and we are defining some of the other informations from the DHCP version 6. And the last message can be DHCP version 6, which means I'm sorry my friend, ask DHCP version 6. We can use our router as a DHCP server in IP version 6 networks too, similar to IPv4. In this configuration, router 1 offers DNS server and domain name, as you can see. The first, we are defining a pool again by typing IP version 6 DHCP pool and the name of the pool, and we are defining the DNS server and the domain name. Okay, and in here we have also another configuration, IP version 6 and the other config flag. This flag is required as it will inform clients through router advertisement message that they have to use DHCP version 6 to receive extra information. We can also use our router as a DHCP version 6 relay too, and this router in here forwards the DHCP broadcast packets to the DHCP server, and here is the configuration of the DHCP relay in IPv6 networks. We are getting into the interface mode again, and the command is this time IP version 6 DHCP relay destination and the IP address of the remote DHCP server.